Hey class, I wanted to make a video for this workshop problem here where we have these two different blocks, mass 1 and mass 2, that one is on the ramp and 2 is just hanging. Now we're asked to figure out the amount of time it takes or how long it takes for block 1 to move 1.25 meters, and since 2 is larger than mass 1, I'm pretty confident 1 is going to move up and mass 2 is going to move down since it's the larger one and isn't impeded by the ramp. And so to figure this one out, I immediately think time and distance, I think kinematics. However, I know that given only the distance, I won't have enough information, even if it starts from rest, as it does in this case. So I'm going to need to find the acceleration first. So that immediately sends me to think about free body diagrams, some of the forces, because acceleration is what links the Newton's second law stuff to the kinematics. So if I look at block 1 and do a free body diagram for it, I know that it's going to have a normal force perpendicular to the surface of contact. It's going to have a tension, a pull from block 2 pulling up the ramp, and it's going to have its weight force or the force of gravity going straight down. And for me, I'm going to go ahead and define my axes as parallel to the surface of the ramp and perpendicular. You don't have to do that, but I find that to be very advantageous in this case because I know or have observed that my block is going to be accelerating, and the acceleration should be up this direction, up the ramp, and so this way all of my acceleration is in the x direction, which is what we're going to try to find, and my acceleration in the y direction is going to just be 0 since it's flat and not accelerating up in that direction. So if we go ahead and try to do the sum of the forces equations here, sum of the forces in the x equals mass times ax, then what I would have is the tension minus the component of weight down the ramp. So if this is my angle theta, then I could go ahead and observe that the weight force in the x is going to just be weight times the sine of theta, and the weight force in the y is just going to be the weight times the cosine of theta. So I'm going to have t minus m1g sine theta equals m1 times ax, which I'm just going to call a because the a of block 1 and the a of block 2 have to be the same if they're tied together. You can't accelerate two objects in a tensioned rope at two different rates, or else the rope would be expanding, breaking, or not holding tension. So this is great. However, I don't know A and I don't know the tension T, so I need to stop here and move on to look at block A or look at forces in the y direction. Now if I wanted, I could do forces in the y direction for fun. Sure, why not? Sum of the forces in the y, I'm just going to squeeze it in down here, equals 0, and so I'm going to have normal minus m1g cosine theta. Ooh, that's sloppy. Let's redo that. So I'm going to have m1g cosine theta equals 0. So I could solve for the normal, but that doesn't help me get the tension or the acceleration. So instead, I'm going to go ahead and move over to block number 2. So if I look at block 2 here and do a free body diagram for it, I observe that it's got the tension pulling up, and we got m2g pulling down, and this guy I know is going to be accelerating in the downward direction. And so what I'm going to do in that case then, I'm going to go ahead and define my axes, and I'm going to call down the positive y direction. You don't have to do this, that's fine, but if you call up positive, your MA needs to be negative since the acceleration is down, and many students forget that, and so that's why I'm going to flip it upside down. So if I do sum of the forces in the y direction equals MAY, again this AY is the same A as over here, because they're tied together, and so in this case I would have m2g minus the tension equals m2 times that same acceleration. So again, I know the weight, but I don't know the tension or the acceleration. However, now I have two equations with the same two unknowns, and algebra can allow us to solve. So for example, if I solved this equation for t, it's just going to be equal to m2g minus m2a, and then I can just plug that t in over here and get my acceleration value because I'll have all the values in there. So that's all I'm going to do on this one. I'm going to let you guys take it from here to figure out the rest. But that's really the key when you have these multi body systems here. Do free body diagrams for one, some of the forces for that guy, do it for the other one, and then start to see where you can solve by putting things together. Hope that helps you all out, and have yourselves a box-worthy evening.